Hello and welcome to Tiny Code Christmas Extra Day 2. Today we're going to be taking a look at another classic demo scene effect, Metaballs. This video is designed for people who've already completed Tiny Code Christmas, so if you're new, there may be some concept in this video that we haven't covered yet, so you can feel free to leave this and come back to it when you finish Tiny Code Christmas. The code for today's effect is on the website to save you typing it in. So let's take a look. We got Metaballs in Tick 80. And we got some Metaballs in Pico 8, adapted slightly for the limitations of that platform. Let's dive into the code, and I'm going to take a look at the Tick 80 code first. This is a very basic, non-size coded implementation of Metaballs, designed to make it easy to understand how the effect works. So this effect has two balls, x1, y1, x2, y2, defined the center. We have a distance function. If you were ever wondering when you were going to use Pythagoras' theorem, this is it. And this simply takes the horizontal and vertical difference between 2 points, squares them, and gets the square root. And that gets us the distance between those 2 points in pixels. So we're going to come down to our tick function. We're going to make t equal to time divided by 500. Slow it down a bit. And I'm going to set x1 equal to 120, the center point of the screen, plus mat.sine and mat.cosine on the x2 so that they'll move back and forth. So that's just a bit of animation. So this part here is the real Metaball effect. We have y equal 0 to 135, x equals 0 to 239. We're going to visit every pixel on the screen and we're going to get the distance from that pixel on the screen to the first Metaball, to the second Metaball. We're going to add that together and plot that pixel. So we're going to use the kind of an inverse square law here, where we get the distance and then we divide a number by that distance, and we can vary these numbers to make our effect look exactly how we want it. Then we take these two inverse distances, add them together, and we plot a color on the x and y coordinate. And I'm using a min function here so that it's going to choose the minimum of either the distance or 16, so that we're not going to wrap around and have two colors. So it's just going to make sure that it maxes out at 16. Let's take a look. We have the two balls moving, and you see when the distance between them is sufficiently close, they'll join to become one entity. So this is the basic Metaball effect. This code has a lot of optimization that can be done to it. There's some redundant variables here. This distance function can be inlined. You can get away without having to do the square root. And there's a lot of other things you can do in performance too. On Tick 80, it's going to run fairly well, but it's still probably not going to run at 60 frames per second if you do anything fancy. And on Pico 8 over here, I've had to make some adjustments to get this to run at a reasonable frame rate. So if I hit Control P, you can see that it's running at 30 frames per second, no problem. And the difference here is obviously I've adapted the screen coordinates to work with Pico 8, but instead of visiting every single screen coordinate, I have a for loop that iterates 1,000 points, and it generates a random x and y coordinate, and it calculates just for that coordinate. So instead of visiting every pixel on the screen, it's going to visit a random selection of pixels, and that gives us this nice dithering effect as well that you can see here. So your challenge is obviously to make the most tiny optimized Metaballs that you can. There's a lot of optimization for the code for this on both platforms in terms of size and in terms of performance, so you should have plenty to work with. The code is available in full on the Tiny Code Christmas website, so make sure to check that out. Best of luck.